Hello everyone. Today we are going to see on the topic unsupervised learning based upon the clustering methodology using k-means and EM algorithm. The first thing is unsupervised learning. The task of grouping a data points based on their similarity with each other is called as clustering or cluster analysis. This method is defined under the branch of unsupervised learning, which aims at gaining the insights from an unlabeled data points, that is, unlike supervised learning. Clustering. Clustering it aims at forming a group of homogeneous data points from a heterogeneous data set. It evaluates a similarity based on a metric like Euclidean distance, cosine similarity, and then it forms a group of points with the highest similarity scored together. The diagram represents the clustering formation. The next thing is k-means algorithm. In this slide, we are going to see about what is a k-means algorithm and what are the methodologies have been used for making a k-means algorithm. The k-means algorithm is an unsupervised learning algorithm which will group the unlabeled dataset into a different clusters. Here, the k it defines the number of predefined clusters that need to be created in the process. We can declare the k-means algorithm which will determine the best value for a k center point or a centroids by an iterative process. And also it assigns each data point to its closest k center. The diagram represents the k-means before k-means and after k-means, which means it forms a cluster or a k-center using the k-means algorithm. The working of a k-means algorithm will be explained below. The first step, we need to select the number of k, which means to decide the number of a cluster. And then we have to select the point or a centroid which forms a center for splitting up of a data. The next thing, we need to assign each data point to their closest centroid, which will form the predefined k clusters. And next we need to calculate the variance and place a new centroid of each cluster. And then we have to repeat the third step, which means we have to assign another data point to the closest centroid. And last, if we need to assign the requirements, and then we have to finish the step 4. And last, we need the model have been ready. So these are the working of an k-means algorithm given in these steps. The next thing, we are going to see about a sum which describes the two variable m1 and m2, and also it consists of x and y axis scatter plot of these two variables which are given below. So considered in the diagram with n number of data points in a x and y axis which consists of scattered plots. So considering this as a problem, we are going to split up the data into two division halves of two variables m1 and m2. By using the k-means, we are going to form a structure which forms a centroid as a center point and makes the data into two equal halves variable m1 and m2. So following these diagrams, at last we will get two different data structures or data points in the graph. So these are the methodologies used for finding the k-means algorithm. And we are going to see about some common applications for the k-means algorithm. Especially it is used in market segmentation and social network analysis, and also search result grouping in medical imaging and image segmentations, and also anomaly detections. So the diagram represents a raw data which forms a major output by using the k-means algorithm. So these are the content about k-means algorithm. The next we are going to see about EM algorithm. EM algorithm, it is also called as expectation-maximization algorithm. The EM algorithm is mainly used for an iterative optimization method which combines a different unsupervised machine learning algorithm to find the maximum likelihood or a maximum posterior estimates. So here are given the EM maximization algorithm which involves the unobservable latent variables, which is commonly used for latent variable models and can able to handle the missing data. It consists of two steps which are called as E step and M step, which means the estimation step and the maximization step, which are together are called as expectation maximization, which forms an iterative process to improve the model. The figure represents the M step and E step which update the variables and also update the hypothesis, and also the flowchart describes the following algorithm. The next thing, we consist of three steps which are called as expectation step, maximization and repeat E steps. So these steps involved in the process of EM algorithm. And the next thing, the applications. EM algorithm, it applies in various fields such as in data clustering, in ML machine language, and also it is often used in the computer vision and NLP, which is called as natural language processing, and also it is used to estimate the value of a parameter in a mixed model which are such as Gaussian mixture, model and quantity genetics. And also it is used in psychometrics for estimating the item parameters and the latent abilities of an item response. And it also applicable in the medical and also healthcare industries. So these are the some common applications of EM algorithm. The next thing, the major issues in EM algorithm is their advantages and disadvantages. The advantages is speak about it is very easy to implement at the first two basic steps of EM algorithm, which are E step and M step. And also it is mostly graduated, will enhance after each iteration, and it often generates a solution for the M step in the closed form. And next thing is the disadvantages of EM algorithm. The convergence of the EM algorithm is very slow. It can make a convergence for the local optimum only. It takes both the forward and a backward probability into consideration. It is opposite to that of the numerical optimization, which takes only the forward probabilities. So these are the advantages and disadvantages of EM algorithm. So from in this video, we have observed what is a K-means algorithm and EM algorithm, which are under the topic of clustering in the unsupervised learning methodologies. So by using these two techniques, we can easily classify the unlabeled data in the clustering methodologies. Thank you.